On your warm-up, this first shape is a semicircle. If you want to find the area of a semicircle, what formula should you use? Good.
Pi times radius squared.
Okay, so area equals pi r squared. If you look on your formula sheet, that's the area formula for a circle. So since it's a semicircle, we should divide this by 2 because it's half of a whole circle. 3.14 times, what's the radius? 5. So times 5 squared divided by 2. Your order of operations says that you need to square things first. So 5 squared, then times 3.14 divided by 2 is 39.25. Number 2 is just area and perimeter. To find the area, if I drew a line right here, I have one rectangle, and then I have another rectangle. So a little rectangle and a big rectangle. If I can find the area of each one, I just add them together to find the whole area. To find the area of a rectangle or a square, you just do length times width. 2 times 3 is 6. And 6 times 4 is 24. 6 plus 24 is 30. Area has units squared, so this would be meters squared, because it's asking you how many squares would fill up that shape. So if you had like this, 1, 2, 3, 4, 5, 6, that's 6 squares filling the shape. To find the perimeter, we're just adding up all the sides. So this side would be 2, plus this side is 3, plus, what's this side?
3. No. 4.
Okay, so if from the top of the shape to the bottom of the shape is 6, this little part is 2, the rest of this has to be 4. So, 2 plus 3 plus 4 plus 4 again, plus 6 up top, and then this is another plus 4 and a plus 3, so that total is up top is 7. From here to here is 4, from here to here is 3. 4 plus 3 is 7. So there are 1, 2, 3, 4, 5, 6 sides, 1, 2, 3, 4, 5, 6 numbers you're adding. So 26 meters, because you're just measuring the length. So if you had a ruler, you just measure along the side and give your units in meters. Okay? The back is the same thing. I didn't mean to put this on here twice. But again, you can just draw a little line. 6 times 7 is 42. 6 times 10 is 60. 60 plus 42 is 102. Meters squared. Alright, and the last one, this is a shaded region. Sometimes with a shaded region you can find out each part and add them together. This one would be easier to find out the whole area and then remove or erase or take away or subtract the area that you don't want. So the whole shape, 100 times 200, is the big rectangle, is 20,000. The garage, 24 times 30, is 720. The house, 40 times 40 is 1,600. So you have the whole shape, which is 20,000, and you don't want the area of the house because that wouldn't have grass seed on it or whatever you're looking for. And you don't want the area of the garage. So 20,000 minus 1,600 minus 720 is 17,680 feet squared. Questions? Okay, take out your notes. So everything you need to know is on your formula sheet. All of those formulas are going to help you solve the problem. The only thing that it's not going to help you with is critical thinking. So figuring out like what shapes you can break up your composite figure into, or figuring out missing sides. And always remember with semicircles you have to divide by 2, because that's something that's not on there. So this is how can we use formulas for regular polygons to find out the areas and perimeters of composite figures. A composite figure is made up of 2 or more regular polygons. We can find out the area and perimeter of irregular polygons. And composite shapes by breaking them down into shapes we are familiar with. So this first example looks like an arrow. What 2 shapes do you see? Good. So if you know how to find the area of a triangle and you know how to find the area of a rectangle, you can find the area of that whole shape. And perimeter is just adding everything up. So to find the area, here's my rectangle. To find this area, 12 times 2 is 24. And here's my triangle. Remember, the area of a triangle is 1/2 base times height. And the base and the height of a triangle are always perpendicular. So you got to find that right angle, or 2 sides that intersect at 90 degrees, because that will be your base and your height. So here's my base. What's this distance? 4. 1 plus 2 plus 1 is 4. And this perpendicular side is my height. It goes straight from the bottom to the top, not at a slant. What's the height? Good. Not 10. 10 is not the height. That's the slanted part. The height needs to go from the bottom to the top and be perpendicular. So, to find the area of the triangle, 1/2, 4 times 9. And then we just add up our 2 areas. 24 plus 18 is 42. To find the perimeter, we just got to add up all the sides. It's helpful if you trace them, just so you know you're not missing any. So this side is 12. This side is 2. What's this side? 12. It's not labeled, but it's the same as the top. Plus 1. What's this diagonal? Plus 10. Plus 10. Plus 1. And then I ended here, and I had already traced that over in green, so I know I already counted it. You could also make X's on lines after you've counted them or put them into your calculator. So 24 times 48 centimeters. Just add up all your sides. Are there questions yet? Okay. Our next example is a funny looking shape. These dotted lines are not part of this perimeter. Your perimeter is just when you trace the outside. So 1, 2, 3 semicircles are on the perimeter. None of that inside stuff is there. Those dotted lines are there to show you what the diameter of each semicircle is. So, to find out this circumference, we do pi times the diameter divided by 2. I'm using this formula, circumference equals pi times the diameter. If they give you the radius, you can do 2 pi r. Alright, pi times 11 divided by 2 is 17.27. So this semicircle with a diameter of 11 has a circumference of 17.27. So this one's going to be the same. This is also 17.27 because they have the same diameter. And then this semicircle, 3.14 times 8, don't forget to divide by 2 because it's a semicircle. And you get 12.56. And to find the perimeter, add up all the sides. Alright, this next one will be on your test or on a quiz or on activities that we do. It usually has like a pool or a garden, but it's the same sort of idea where there's a border around some sort of rectangle and you want to find out what the perimeter of the inside rectangle is. So, if you were to look at this, from one end of this frame to the other end of the frame is 30 inches. And I don't want to find the perimeter of this shape with the frame. I want to find the perimeter of the poster. So from one end to the other of the poster. So this is not 30 inches. What's this distance? How did you get that? Good. The frame is 2 inches on both sides. So right here, that's 2 inches you take away. And on the other side, because there are two sides of a frame. So 30 minus 2 on one side, minus 2 on the other side, is 26 inches for the bottom of that poster. When a lot of people do this problem, they only take away 2 on one side. But there are two sides to that frame. Alright, and how long is the side of this poster? 20. Because again, there's 2 inches on the bottom and 2 inches on the top that you want to take away. So the hard part of that problem is finding out those missing sides. To find the perimeter, 26 plus 20 plus 26 plus 20. Oops. Alright, do you guys want me to keep going over these problems, or do you want to try the ones on the back on your own? Okay, I'll keep doing them. Alright, this one on the back, we're finding the area of the shaded region. So, what two areas do I need to find before I can find the shaded region? The circle and the rectangle. To find the area of the circle, our area formula is pi r squared. What is the diameter of that circle? 0.4. From the top of the circle to the bottom is 0.4, just like the top to the bottom of this rectangle. And what's the radius? Okay, so 3.14 times 0.2 squared, and that will give us the area of the circle. 0.1256. And how do I find the area of a rectangle? Okay, and what's the length and the width? Perfect. And once I know the big area, how am I going to find the shaded part, this part without the circle? Okay, good. So the big area is 0.36. The part I don't want to include is 0.1256. You get 0.2344 centimeters squared. All right, example 5, there's more than one way to solve this problem. I will show you the way that I think makes most sense, but just know that if you have a different way of solving it, as long as you get the same answer, that's fine. So it says the following pattern is made using a 21 by 21 inch square. Some problems might give you this square without any labels, and you have to read in the problem that this shape is 21 by 21 inches, or this shape is 15 by 15 inches. You have to read that. Each section is divided evenly. Find the area of the shaded region. So from the top to the bottom of this square is 21 inches. How many squares fit along the side? 7. So if there are 7 squares divided evenly among those 21 inches, or 21 inches divided evenly among the 7 squares, how many inches is each square? 3. They're squares, so both sides are the same. So one shaded square has an area of what? 9. Okay. It didn't say find the area of one shaded square. It said find the area of the shaded region, which would include all the shaded squares. How many shaded squares are there? 25? Okay. So each square has an area of 9 inches squared. We're going to multiply by 25 because that's how many total shaded squares there are. And what's 9 times 25? Good. You could solve this by finding the area of the whole region and say 25/49 are shaded, I think. And so multiply the area, like 21 times 21, multiply that area by 25/49. All right, and the last one, this is a rectangle. It has another rectangle, a trapezoid, and a triangle that would be removed if you're finding the shaded region, but it also just has 2 triangles. So instead of finding the whole area and subtracting 3 pieces, We could just find the area of these triangles because we know how to find area of a triangle. So, this is one triangle traced in blue. I'm going to draw it out here so we can see it nicely. What's the base of this triangle? 7, and what's the height? So what did you say? 17. From one side of the rectangle to the other is 20. But this doesn't go all the way to the top. It stops 3 inches below the top. So 20 for the whole thing minus the 3 that it doesn't reach is 17. So to find the area of this, 1/2, 7 times 17. And you get 59.5. The other triangle is this pink one. So I'll draw it out here so we can see it. And these triangles are not the same. What's the base of this triangle? Okay, and what is the height? Okay, so the whole thing is 20. It doesn't reach all the way to the left-hand side. It's 8 inches smaller than the left-hand side. So 20 minus 8 is 12. And when we take our two areas and we add them together to find out the total area of the shaded region, we get 95.5. So, all of these questions just apply your formulas, but you have to do some critical thinking and analyzing and seeing what kind of shapes there are and figuring out how to use those formulas.